Right, next up is a problem I already love because I think it was the first medium problem that I truly understood when I was first learning. Container with most water. It's a classic two-pointer problem that looks tricky at first, but has a beautiful intuitive solution. The problem is this: you are given an array of non-negative integer representing vertical lines. Your goal is to find two of this line that can trap the most water between them. To find a potentially better container, we had to move one of the pointer inward. Which one? The golden rule: we always move the pointer of the shorter line. The amount of the water is always limited by the height of the shorter of the two lines. If we move the taller line's pointer inward, our weight gets smaller, but our height is still limited by that same short line. The area can only get smaller or stay the same. But if we move the shorter line's pointer, we take a change. Alright, let's trace our algorithm with the classic example. We'll keep track of our pointer and maximum area we have found. We start at the left at index 0, right at index 8. The distance between left and right is equal 7. The height is limited by the shorter bar. The area is 8 multiplied 1 is equal 8. Maximum area is now 8. The left line is shorter, so we move it. Now left is at index 1. Right is at index 8. The width is 7. The height is limited by the shorter bar, which is 7. The area is 7 multiplied 7 is equal 49. Maximum area is now 49, a huge improvement. This time, the right line is shorter, so we move right. Now left is equal 1, right is equal 7. The width is 6. The height is limited by the shorter bar, 3. The area is 6 multiplied 3 is equal 80. This is not bigger than 49, so maximum area remains 49. The right line is shorter, so we move to right. Left is at index 1, right is at 6. The width is 5. The height is limited by the shorter bar. Well, they are equal, so height is equal 8. The area is 5 multiplied 8, still not bigger than 49. Maximum area remains 49. Since the heights are equal, we can move either pointer. Let's move right. As the process continues like this, the pointer move closer and closer. Always discard the shorter line and recalculate the area. So we saw our maximum area is 49, was found early, and no other combination was able to beat it. When the pointers finally meet, the loop ends and our final answer is 49. We define our tools. Max area is equal 0, left is equal 0, right is equal end of the array. Our loop continues as long as our pointers haven't crossed. Calculate the width of the container. Calculate the height is limited by the shorter of the two lines. Calculate the area of the current container. Update the maximum area found so far. Move the pointer of the shorter line inward and return maximum area. The left and the right pointers start at the ends and move toward each other. Each pointer will only traverse the array once. This gives us a single path solution with a beautiful time complexity of O(n). We only use a few variables to store our pointers and the maximum area. Therefore, the space complexity is constant O(1). Don't forget to like, subscribe, and give a comment. See you in the next one.